You may recall that part of the purpose of talking about trees was because they can be used to express relationships and represent these relational pieces of different information or different structures that we see. So we're going to examine that by looking at a way that we can represent relationships in mathematical expressions. So to do that, let's think about how you would describe the steps for evaluating the expression 3 times 6 minus 2 times 7. Think about the details of how you would explain those steps to someone. What is the first step? What is the next step? What is the next? And we'll use that information to talk about the relationships there and how those can be represented in a tree. So pause the video, and think about those steps that you would describe. Okay, if I were to describe this expression, I would describe it as first we multiply 3 and 6, then we multiply 2 and 7, then we take the result of each and subtract them. Subtract the results of each. And we could get more specific with the details of the numbers that would come out as results or that sort of thing, but we have a description here of the process that you might follow. So from that description, we can pull out some information about some relationships here. If you think about it another way, there are two sub-expressions. There's the multiplying 3 and 6 sub-expression, and there's the multiplying 2 and 7 sub-expression. To be able to get the final value of the expression, I need to do both of those sub-expressions first before I can do that last step of the subtraction. So there's a relationship here. There are some sub-things from some outer thing, the whole expression. And that's what trees can be useful for. So we could think about these different pieces of the expression as parts of a tree. We have 3, we have times, and we have 6. Those are a little subtree here where the operation is apparent to both of the values that it's going to act on. And then we'd have another subtree with 2 and 7 and their multiplication. And those are another little subtree here that represents the parent of the multiplication, and what's it going to multiply? Well, it will multiply the values of its two children. And then at a higher level, we've got the minus that will represent the last step in the operation, in the expression rather. And what's it going to do? Well, it will need the values of its two children in order to be able to evaluate the whole expression. The whole expression is represented sort of by this root, this last operation that needs to happen of the minus there. So we've got a relationship in the order of operations and the sequence of which operations have to be done before which other operations, and another relationship in the two values that any binary operator is going to require to be able to calculate it. And there are a few other little features that we could point out about this tree that we've built. So it represents the relationship through the order of operations. So it represents relationships, order of operations, and operator to its operands. Those are some relationships that are represented in this tree here. The leaf nodes are values, they're operands that they don't need evaluated. We already know their value, or they might be a variable and we could just look up that value, but they don't take any special work of doing an evaluation on them really. Whereas the internal nodes are operators, and they require knowing the values of their children to be able to calculate, to be able to perform the operation that that operator represents. We have to know the value of 3 and 6 here to be able to do the multiplication there. And likewise, we need to know the value of the result of doing the left multiplication and the right multiplication before we can do the subtraction. But what we'll find is these are very useful in being able to represent these expressions, and as we look at those expressions, as we move on beyond today's stuff, we'll see that the structure of these expression trees allow us to think a little more about how we move through a tree and how we use the values within that tree. So for today, you'll look at the details of these expression trees and how they can be useful in evaluating. And later we'll look at building them and at sort of navigating them and a little more details of those. So for today, as you think about these expression trees, take some time to work on part A of the expression trees and traversals activity.